With all these things given, what is the sample that I am coming across? Height from the surface of the earth is 1500 meter. By general definition of density, mass divided by volume. So the area covered by the rain is 2 into 10 power 2 meters. But I am asked to calculate the force, resistive force. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. In my previous session on the chapter Work, Power and Energy, I solved a few numericals from the past exam papers. Hope you have watched this session, you have practiced the numericals, and you have come prepared for today's class. In my today's session, I will work out a few more problems on the chapter Work, Power and Energy. The first one, a train of mass 10 power 5 kg. There is a train of mass 10 power 5 kg which is moving with a uniform speed of 30 meter per second. Uniform speed of 30 meter per second on a level road. If the resistance due to friction of air is 0.5 Newton for 100 kgs, I have to calculate the power of the engine. So the power of the engine has to be calculated in this case. So as we do, we will first pick up the data, which will help me to solve the problem easily. Collecting data will avoid any confusion to understand what has to be calculated. So there is a train of mass 10 to the power 5 kg. Train of mass 10 power 5 kg moving with a uniform speed of 30 meter per second. Uniform speed of 30 meter per second. Now, the problem is very interesting. Resistance due to friction. Andre, frictional force is 0.5 Newton for 100 kg. So he says frictional force here is equal to 0.5 Newton for every 100 kg. Yesterday, frictional force, it is 0.5 newtons for every 100 kg. Then what is the actual mass of the train given? 10 power 5 kg. Therefore, net frictional force equals 0.5 divided by 10 square. 100 na 10 square anta barkondidini into 10 to the power 5. Actual mass of the train is 10 power 5. So this turns out to be 500 Newton. So the net frictional force is 500 Newton. Now, knowing force, knowing velocity, how do I calculate power? I know power is equal to force into velocity. Force into velocity gives me power. Force is 500. Velocity is 30. So 1500, 1, 2, 3, 15,000 watts will be the power. See, if I know the expressions, it is very, very easy that I can solve the question. Next one, a beautiful problem. It says, cluster of clouds. There is a cluster of clouds at a height of 15,500 meters above the earth. Cluster of clouds, height from the surface of the earth is 1,500 meters. It bursts and rain falls, covering an area 2 into 10 power 2 meters. This clouds, this cluster of cloud is blasting and raindrops fall, covering an area of 2 into 10 power 2 meter with a depth 1 centimeter. I have to calculate the potential energy stored in the clouds. With whatever data is given to me, I am calculating the potential energy stored in the clouds. So my first configuration is to understand what is the potential energy of the clouds here. It is nothing but the work done to raise the water as clouds to this height is the potential energy. So here, very significant, potential energy is nothing but work done to raise water level to this height above the surface of the earth. So he says the rain is covering an area which is 2 into 10 power 2 meters. So the area covered by the rain is 2 into 10 power 2 meters. Now first, I will calculate what are the prerequisites I require to calculate the potential energy. So I told potential energy is nothing but the work done here, which is mgh. So I have h, g is known. The only thing I want is mass, where mass is volume into density. Again, density is known. So, here the hint lies in calculating volume. So, volume here is nothing but 2 into 10 power 2 into the depth. So, what is the depth here? So, this is actually 10 power 6. 2 into 10 power 6. Depth is 1 centimeter. So, which is minus 2. So, this is 2 into 10 power 4 meter cube. So, volume is calculated. Now, as I told, mass is volume into density. By general definition of density, mass divided by volume. So mass is volume into density. Volume is 2 into 10 power 4. Density of water is 1000, which is 10 to the power 3. So this is nothing but 2 into 10 power 7 kg. So mass is calculated. Work done is simple. mgh. 2 into 10 power 7 into g approximately 10,500. So when we simplify this, so this turns out to be 20 into 1,500, which is 1, 2, 3, 4 into 10 power 7 joules. So 2 into 10 power 7 into 10 into 1,500, nearly so many joules. So again, we have calculated a simple task here. The next question. A metal sphere is tied to one end of an inextensible string. Metal sphere, it is tied to one end of an inextensible string of negligible mass and rotated in a vertical plane of radius 8 meters. If the speed of the sphere at the highest point is 80 meters per second, I have to calculate the speed of the sphere at the lowest point, taking g is 10 meters per second square. So this I will leave as an assignment. I want you all to go through this problem, collect the data, know what is given, what has to be calculated, and formulate a relationship between them. Next one, calculate the average force. Force in calculate ಮಾಡಬೇಕು. required to stop a bullet of mass 50 grams, which is moving with a speed of 300 meter per second, as it penetrates the wooden plank whose thickness is 0.1 meter. So I have to stop a bullet of mass 50 grams. Mass of the bullet is given 50 into 10 power minus 3 kg. ಗ್ರಾಮಲ್ಲಿರೋದ್ರಿಂದ 50 into 10 power minus 3. It is moving with the speed. Initial speed is 30 meter per second. You are stopping the bullet. The bullet is brought to rest. You are bringing the bullet to rest, which means the final velocity of the bullet is 0. And the distance it penetrates is 0.1 meter. With all these things given, what is the sample that I am coming across? It is moving with a speed 300 meters per second. It strikes an wooden plank, its velocity reduces, which means it is losing its kinetic energy. So first, we will calculate the loss of kinetic energy. So this is half mu square minus half mv square. This goes off because final velocity is 0. So this is half into 50 into 10 power minus 3. U square is 300 square. So 300 square gives me 9 into 10 power 4. 9 into 10 power 4. So this goes 25 times. So 25 into 9 is 225 into 10 power 1. So 2250 joule. Now I have calculated what is called as loss of kinetic energy. But I am asked to calculate the force, resistive force, the force applied by the bullet on the plank. Good. By work energy theorem, work done is loss of kinetic energy. See, a very beautiful theorem which says loss of kinetic energy is nothing but work done. So W is 2250 joule. Now with this, how do I calculate force? Sir, don't I know the definition of work now? Yes, very clearly. Work is force into displacement. So force is W by S. So this is 2250 divided by 0.1, and the answer is 22,500 Newton. So this gives me the amount of force. The last one. Here, if you are trying to understand the problem, where I have to calculate the speed of the block when it moves through a distance of 0.3 meters. The force constant, or what is also called spring constant, is mentioned. The mass of the block is 2 kgs. Applied horizontal force is 8 Newton. Here I have to calculate the speed of the block when it moves through this distance. Here, work done by the force is nothing but change in kinetic energy plus change in potential energy of the spring. So, the work done by the force is converted as change in kinetic energy plus change in potential energy of the spring. So, W equals half mu square plus half kx square, or F dot S is half into mass of the spring is 2 kg, 2 into u square plus half spring constant is given to be 20 Newton into the distance is 0.3 meter. See, this is one example where very particularly I wanted to show, if you don't collect the data and try to simplify, how difficult it becomes. Collect the data on side, immediately you can simplify the terms. So, on simplification, here u turns out to be 1.22 meter per second. So students, with little bit of depth and expressions, very clearly I could solve problems from this chapter. The next we start a very interesting chapter called oscillations. Until then, have a good time. Thank you.